Okay, in this video we're doing vector problem solving, and it could be a situation something like this where you've got a current pushing you right while you're trying to swim forward, or it could be a situation like if you're flying in an airplane and you've got the wind blowing you or something like that. So this is sort of what it looks like, and then we're going to be using a lot of trig and distance formula in there. But at any rate, let's go over this and then we'll see if we can solve the problem. So in still water, this person's swimming forward at 1.5 meters per second and the current is pushing them right at 0.5. If they dive in and swim straight forward, what is the actual current speed and direction going to be? So basically they're going to be trying to swim forward at 1.5, but then they're going to be pushed right at 0.5. So we need to find this resulting vector going up there. Okay, that's good. So if that's 1.5 and that is 0.5, then we can find the length and we can find the direction. So pretty much what it's going to be is, well, C is the current velocity vector. So this is C equals. S is the velocity vector if the water was still. So S equals that. And then we're going to basically be adding them together. So if you like it, S is sort of like 1.5 in the Y, and then the current is pushing you right like that. So F is the total, so it's going to be 0.5 and 1.5. So we could find the angle, the distance of F if we like. So that's 0.5 squared plus 1.5 squared, and we could work that out on a calculator. There we go, 2.5. And then if we go and take the square root of that, it's 1.581. Now you're going to have some units on here. I believe we're in meters per second. So that length there has 1.581 meters per second. Now we also need to find this angle. So if we sort of step it out, we got this angle here. I want to use the two sides that I actually know already, just because of like rounding reasons and stuff. We don't want to use this new number we found. But this is a right angle triangle. So you're going to get tan of theta equals opposite over adjacent. We're going to use here because we have the opposite and adjacent. So tan of theta equals 0.5 over 1.5. So if we like theta equals inverse tan of 0.5 over 1.5, just like that. So what you want to do is make sure you calculate it is in degrees, not radians. And then you're going to go inverse tan of 0.5 over 1.5, just like that. Yeah, 18.435. Great. Okay, so that's good. Then we need to go, what direction should Jack aim to swim so that it'll correct his direction? So actually we should probably do our previous one with the sentence answer. So actual speed is 1.581 meters per second, and actual direction (18.435 degrees), and that's this angle in here. And then the length is 1.581. Okay, so that's pretty good. So then what we need to do for part B is we need to figure out, well, you're kind of going to be swimming up left to battle the current. And then when we put on this 0.5, we should get back to like fully up if we're trying to swim from A to B. And we know that the length here has to be 1.5. So yeah, that's pretty much what you got to do, because you can swim at 1.5 meters per second. You can swim at any angle you want, and you're basically going to be swimming up left, then push right, and that will give you a result of forward. So that's enough that we can actually figure out the angle, because the angle we want is this angle here. So now I've got opposite and hypotenuse. So sine of theta equals opposite over hypotenuse. That can actually work out. Sine of theta equals 0.5 over 1.5. So sine of theta, we're going to do inverse sine, 0.5 over 1.5. And you're going to get 19.471. So theta roughly equals 19.471 degrees. So that's this angle here. So should swim at 19.471 degrees. So that, there we go. And then if we want to work out the speed, so if we call this like A, B, and C, C squared equals A squared plus B squared. That's Pythagoras. So that tells us if I want B on its own, B squared equals C squared, take A squared. So B equals square root of C squared, take A squared, which is square root of 1.5 squared, take 0.5 squared. Let's work it out. .414. Should swim at that speed. Actual forward speed is 1.414 meters per second. So that's how fast they go forward there. So yeah, it's sort of like if you're swimming up here against the current, then getting pushed back, some of your energy is going into fighting that current. So even though you can swim at 1.5, you're only going to swim at 1.414 because the other bit is going into fighting the current. That's what's going on there. So this is an example of a worded problem. They're not particularly easy. All you have to really do is just draw diagrams and use a lot of true distance formula.